Let's discuss the Huffman coding algorithm. Huffman coding is a source coding algorithm, and in general, any source coding algorithm is a mapping from set of symbols to binary code words. If you take the collection of all binary code words assigned by an algorithm, that set is called a code. Now, we previously saw a special subclass of source coding algorithms, which are source codes, which are variable length codes. And Huffman coding assigns variable length codes. An example of variable length codes we saw previously is the Morse codes. A key idea behind Morse codes is to assign shorter code words to more frequently occurring symbols. So for example, here, the letter E has the shortest code word in Morse codes because E is the most frequently occurring letter in English. Okay, and as we will see, Huffman codes are also based on a similar idea. The input for the Huffman algorithm is a probability distribution on symbols, and the output is a binary prefix code. The algorithm itself is actually quite simple. There's a loop and there are two steps within the loop. And once you're out of the loop, you'll actually create a binary tree. And then you're going to just read off the prefix code words from the resulting binary tree. So let's look at the two steps within the loop. Remember, we are starting with a probability distribution on symbols. So the first step would be sort the symbols in descending order of probabilities. So once we have a sorted list, then we're going to combine the symbols with the two smallest probabilities. That means the last two symbols, will combine them into a single symbol, and the probability of the new symbol will be the sum of the two probabilities, right? So once we combine, we'll have a new probability distribution where the number of symbols is one less than what we had before. So we keep repeating this. So in each iteration, we'll reduce the number of symbols by one until the number of symbols is just one, and then we will stop the loop. Now, when we'll see through examples that when we are doing this, we are actually creating a binary tree. And when we're done with the loop, we'll have a big tree. And then we're just going to read out the code words from the resulting binary tree. Let's take an example. Here I have a set of symbols and a probability distribution on the symbols. The first step within the loop is to sort the symbols in descending order of probabilities. So here is the same distribution again, but the symbols are sorted according to descending order of probabilities. The second step in the loop is combine the symbols with the two smallest probabilities, right? And the probability of the resulting symbol will be the sum. So here the two smallest probability are C and D, so we will combine them to form a new symbol. So I combined C and E, which are the symbols with the smallest probability distribution, to form a new symbol. And the probability of the new symbol will be the sum of the previous two probabilities, which is 1/4 here. Now I have a new distribution with 4 symbols. Previously we had a distribution with 5 symbols. Now we have one less. We can represent this process of combining on a binary tree. At the beginning, we had 5 symbols. So we will represent each of the symbol with a node, and we will assign a probability to each of the node, which was from the probability distribution. The combining of C and E can be represented like this, where we are combining these two nodes to form this new node with the probability 1/4. Now note that so A, B, D, and C and E now form a new distribution. So then we go to the next iteration. So again, the two steps are sort the symbols in descending order and combine the symbols with two smallest probabilities. So over here, now all symbols have the same probability distribution. So that means we can combine any two, right? Because the ties break in arbitrarily. So let's say I take A and B as the two smallest probabilities, then I will combine A and B to form a new node. This combination will now result in a new probability distribution with 3 symbols, 1, 2, and 3. And then we because the number of symbols is greater than 1, we go to the next iteration. So in the next iteration, again, you are picking the two smallest, two symbols with the two smallest probabilities. Those symbols will be D and C and E. So we will combine these two to form a new symbol now. So here we have a new symbol with probability half, and the symbol is D and C and E. Now we have a new distribution with 2 symbols. So these will be the two symbols with the two smallest probabilities, and we'll combine these two to form a new node. So these two symbols are combined to form this new node. Now the new distribution is there's only one symbol with the probability 1, and therefore if you look at the algorithm, um, yeah, so we repeat this iteration while the number of symbols is greater than 1. So at this point, now we only have one symbol, so we stop, right? So now that we have a binary tree, so we can just, and then we want to assign code words to these leaves here. So, and as we saw in our video on prefix codes, we will just traverse the binary tree and assign the code words to A, B, C, and D. The first step in assigning code words is to assign binary numbers to each edge. So here I've assigned 0 for left edge and 1 for right edge, and I've assigned zeros and ones for all edges. When assigning code words, we just traverse the tree to reach a particular symbol and assign the code word according to the edges traveled. So for example, I have to start at the root, go left and left. That means 0 and 0. So A gets the code word 0 and 0. Similarly, B gets 0 and 1. And I have assigned the code words for all other symbols similarly. I would recommend to pause the video here and convince yourself that these are the code words assigned to each of the symbols. Also notice that the resulting code is actually a prefix code, and we know this because we are assigning the code words according to a binary tree. So the resulting code has to be a prefix code. Another important observation I want you guys to make here is note that the symbols with the smallest probability, which are, if you go to original distribution, the two symbols with the smallest probabilities are C and D. And if you notice in the code words, those are the two symbols which get the longest code words, right? And it makes sense because we are starting to build the tree from bottom up, and we always combine the symbols with the smallest probability, right? So that means the symbols with the smallest probabilities will be at the bottom of the tree, and therefore will get the longest code words. So that's the Huffman algorithm, right? And you can repeat this procedure no matter how long this probability distribution is. As long as it's finite, you can do the same procedure, right? And the algorithm itself is actually pretty quite simple. There is a loop, and there are two steps within the loop. And then once you're done with the loop, you'll have a binary tree, and then you just read out the code words from the binary tree.